Hi students, Mr. Metelsky here, and this video will be covering how to solve systems of equations using the elimination method. And this one I would consider of medium difficulty because this is an example where we can't add and immediately cancel. We have two equations here, negative 3x minus 8y equals 20, and negative 5x plus y equals 19. So remember, the goal of elimination is that if we add the two equations together, we get a variable to be eliminated. Well, we need opposite coefficients to do that. So negative 3 and negative 5 are not opposite numbers. And negative 8, and down here we have an invisible 1. Those are not opposite numbers. So what we're going to do is manipulate one of these equations so that one of the coefficients is the opposite of one of them in the top. Well, right off the bat, I'm drawn to this 1 because we can manipulate 1 easily by multiplying it by whatever number we want. So in our case, up here we have a negative 8. So if we had a positive 8 down here, negative 8 plus positive 8 gets a 0, and those terms would effectively disappear. So what we're going to do is we're going to take this bottom equation and we're going to multiply the entire equation by the number 8. And we can do that. It's not illegal to multiply an equation by a number as long as we multiply that number by everything. So we're going to turn this equation into 8 times negative 5x, which is negative 40x, 8 times 1y, which is 8y, and 8 times 19, which is 152. So this equation is what we call a linear combination. It's a linear combination of this linear equation right here. Now, I'm going to bring this top equation straight over. We're not going to do anything with that. Negative 3x minus 8y equals 20. And now we have two equations when we add, when we add them together, we're going to get something to be eliminated. So if I take these two equations now and add them together, negative 3x plus negative 40x would be negative 43x. Negative 8y plus 8y is 0y. So that's eliminated. And that equals 20 plus 152, which is 172. Now, we have negative 43x equals 172. We can divide by negative 43. And that forces the negative 43's to cancel. And over here, 172 divided by negative 43 is negative 4. So we're left with x is equal to negative 4. Okay. Now, what we're going to do is we're going to take our answer, the first solution, and we're going to plug it back into one of these two equations, the original equations, to find the y variable. So you could plug it into either one. I always recommend doing the one that looks less complicated. So I think the bottom one actually looks less complicated. So I'm just going to rewrite that. Negative 5, definitely not negative 5y, it's negative 5x plus y equals 19. So now I'm going to take this negative 4, which was our x, and I'm going to substitute it in here, where it's being multiplied by negative 5. So this is negative 5 times negative 4 plus y equals 19. So negative 5 times negative 4 is 20. So now we have 20 plus y equals 19. Subtract 20 on both sides. and we're left with y equals negative 1. So there we go. Our final answer, we've got negative 4 for the x, comma, negative 1 for the y. So just a quick recap. We looked at our original two equations. Nothing immediately canceled out or was eliminated when we added them. So what we did was I looked at the y here that had a coefficient of 1, and I thought if we can get that to be positive 8, negative 8y plus 8y, it cancels. So we're going to multiply the whole entire bottom equation by 8, which is called a linear combination. And we got this new equation here. I brought over the original top equation, and we added them together. We were able to eliminate the 8y's, did a little bit of algebra to get our x. We picked the easier equation, we plugged the x in, and we solved for the other variable y to get our final answer. All right, good luck as you're working.